So I have two follow-up questions. Sam, you just mentioned equilibration. My question is, what would be the appropriate, time to equilibrate the membrane for the IVRT and the skin equilibration in the IVPT study, and especially for IVPT study, equilibration overnight, is it acceptable? And is there any concern? Um, Sam, you are on mute.
There, can you hear me now? So I think in discussions that we've had in the past, a 30-minute equilibration has been very common among many investigators. And I'd be interested in getting comments from the panel about the protocols that they use. But there are those who do sort of an overnight equilibration as well, and I think that can be acceptable as well. Now, that wouldn't make sense for an IVRT, so I think we have to be a little bit careful here in being in understanding there are some things that are common for IVRT and IVPT studies, but there are many things that are just fundamentally distinct, and so that obviously would not make sense for an IVRT study. I'd be interested in hearing from other investigators what they consider to be suitable equilibration times.
So I can add to Sam's answer about this question is that conditioning of the membrane for IVRT, it is just simply wetting the membrane, and wetting the membrane depends on different factors. The material of the membrane, thickness of this membrane, and there is a wetting profile for each membrane to approach maximum wetting capacity. And this is done by like some preliminary study for each membrane before IVRT, and we need to know to what extent is that wetting the membrane or conditioning the membrane before the experiment can affect the permeability of some markers through this membrane, and there is no any more uptake that's needed for this membrane. So I do agree with Sam. Usually for most of the hydrophilic membranes that we are using, half an hour would be different. However, some of the membranes are hydrophobic and may require longer time for wetting. When we come to the skin, conditioning the skin is really more critical and more tricky, I would say, because of the structure of skin. So we don't need to overhydrate the skin. However, we need to maintain the physiological condition and function of skin as a barrier to be maintained after thawing and preparing the skin for the diffusion. So we are using some protocol for conditioning the skin before the doing the IVPT testing. So after preparing the skin and having it ready for permeation, then we are conditioning it at 37 degree or 32 degree, I'm sorry, so that we are maintaining the same elastic or elasticity properties of skin as well as the water hydration. And then before the test, we are ensuring that the permeability, the barrier function is maintained through total testing or electrical conductance around the skin, which is a key function about the amount of water in this skin and its suitability for a barrier rule in IVPT.
Thank you. So for overnight equilibration of the skin, is it still required for the, to measure the skin barrier integrity again, like the next day when the real study, the IVPT is going to be conducted?
It 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 shouldn't be, because the skin, once you've evaluated that the system is set up, and you want it to have equilibrated for a certain amount of time before you do the barrier integrity test. But part of the reason that the protocols exist where it's overnight were based upon a protocol where it used a tritiated water barrier integrity test. And so just the time that it took to run all those samples on the scintillation counter would often be such that the protocol had the skin mounted in late in the day, and then the barrier integrity test would be done with tritiated water. Those samples would run on the scintillation counter through the night, and then in the morning, you'd get your test results. Nowadays, I'm not sure if there are many or any labs that still do tritiated water. I think many labs have now moved toward a TWL based barrier integrity test. So the barrier integrity test is actually much more efficient in the sequence of events. And so you can usually let the system equilibrate and do the barrier integrity test and then still get the dosing done that day. But once that barrier integrity test is done, the expectation is that the skin barrier remains competent for a few days through the course of the experiment. And there's been some evidence to show that, up to 72 or 96 hours, that the barrier integrity remains suitable in a skin that's mounted in a diffusion cell and maintained at 32 degrees, across that duration of time. There are other studies where they've used transdermal systems, patches, that have been dosed on the skin, and the permeation kinetics from those patches have given very good results out through 7 days if it's a 7-day wear patch. So I think that first part overnight, there's no indication based upon the fact that the study can run for several days that something has destabilized with the barrier during that overnight. But I also think that it's not very common. I don't know if that those overnight are necessary so much anymore. It's not a bad idea, though, if you have a TWL that you could, do the barrier integrity test just prior to dosing. I think that is probably a good idea. If you feel like your equilibration requires overnight equilibration, then the TWL test can be done prior to dosing as well. Thoughts from the other panelists?
The way we do the studies is like monitoring the TWL or electrical resistivity from the time we mount the skin on transdiffusion cell. One reason why I use electrical resistivity also alongside TWL is the electrical resistivity of the skin is temperature sensitive, and during equilibration the electrical resistivity would go on changing, and then once the equilibration is attained, the resistivity would remain constant over a long time. So that gives me an indication that the skin is kind of homeostatic with the system, and then now it's ready for loading or dosing. So that depends, like sometimes we need about 30 minutes. Sometimes it may go up to 1 hour. It depends on the skin thickness, the region from which the skin is harvested, and several other things.
It's a really good point. I think part of what makes it a little bit challenging to put a specific number on this is what happened even as the cell was being set up. So if we're talking about skin, for example, and the skin was left and basically has dried out on the bench, and during handling, it's just been out for a long time. It's difficult to know when we see people's protocols, when we see people's data, how was the skin handled even before it was mounted on the diffusion cell. But if it was thawed, where it was taken out of the freezer, and as it was thawing, it wasn't soaked, that it might have just been rinsed, or it might have been in a plastic bag while it was thawing, that the underside of the skin was kept moist, prior to dosing, so it wasn't all drying out, and then it was dosed. That equilibration, the temperature equilibration, happens relatively quickly, and because these are very, very thin, whether it's a synthetic membrane or whether it's skin, it's pretty thin, so the temperature equilibration happens relatively fast, and you can test that. Bringing the skin to a physiological state of hydration depends a little bit upon whether you've been maintaining it that way or whether it's dried out on the bench. And that's why, it's helpful to consider all of those things leading up to the equilibration as well. John, what has your experience been?
Well, this may not surprise you. We have different equilibrations depending on the system, and so those equilibration really are dependent on the systems. For example, in the flow through cells, we want to make sure that the skin comes up to temperature. They're pretty easy to set up, so we set those up and then let the system run and actually perfuse. It goes into waste anywhere from 30 minutes to an hour. That's pretty common for that system. IVRT depends on how many diffusion cells we're setting up. Some of that drives it too. You start getting into larger volumes, especially in IVPT, less so in IVRT. And then what it goes into, for example, we've just been designing a new cell warming block. We spent a tremendous amount of time on making sure that heat sink could be maintained. So for me, it's not just about initial equilibration, but it's also the duration. So we look at both ends of the spectrum.